Good morning, ladies of calculus. Welcome again to room 15, where learning never ends. Doesn't even end when I'm away for jury duty like I was yesterday. So what I did already just before class is I came and did the first of these two. So I want you just to look at those and see how you did those. So here's the first one, which you end up getting D. Did you get that?
We don't have that paper. Yeah,
You don't have that one? You don't have this one? Okay. That must be the wrong one then. Let's get to the right one then. The 4-chain rule. So not this one either. This one here?
No.
This is the one, okay. All right, sorry I got to the wrong place. Okay, let that function define which following is equation of the line tangent to the graph at the point x equals -1. So then you have a point, right? You have a point at -1, comma, question mark, and then if you plug in f of -1, you're going to get -4 times -1 cubed, so that's going to be -1, right? And then we have -5 times -1 plus 3. So I'm looking at 4 plus 6, no, 4 plus 5 plus 3, is that right?
12.
So that's going to be 12? Yeah, 12. So 12 would be it here, right? Okay, so next we would go ahead and find the first derivative, which is f prime of x. And so we're going to get, for that -12, x squared minus 5, is that right? Is that right?
Yeah.
F prime of -1 is going to be equal to -12 times 1, because -1 squared is 1, minus 5. So that's going to be -17. Is that right? Doesn't look right. When x is -1.
You gotta square it with 12 times -1, but you also put it in 1.
Wait a second, because -1, oh, that's right, because that's going to be negative.
And also square it. Oh, yeah.
Yeah, -1 squared is going to be positive, right? So you're going to get -12, -17. That looks right, but it should see which is a tangent line. So there's something that's missing here, because there should be one of these slopes here, shouldn't there? But shouldn't it be? Unless, the only thing I can think of, that this is a stray mark here, right?
Yeah.
What if this is plus? I bet that's what it is.
I don't think it is a -4.
Yeah, so what it is, that's going to be just plus. So I read it wrong, so that's going to change things, right? Yeah, so let's fix that, because I just didn't see any answers for that kind of a slope. So if we change that, so we're going to get 4, we get -4 plus 5. -4 plus 5 is 1 plus 3, that's going to be 4, right? And if you do that, that's going to make this 4. And so if we fix that, that's going to be that, and we plug in, yeah, -1 squared, that's going to be good. So we're going to get 12 minus 5, or 7, right? Does that look better? Okay, so now we're going to get y minus 4 equals 7 times x plus 1. And we do that, we get y minus 4 equals 7x plus 7. And then if we add 4 to that, we would get 7x plus 11, in which case C is the right answer. So that would be that one, okay?
I'm so confused.
What are you confused about?
Can you just start from the beginning and just start over? Because I don't know what you did.
Okay, yeah, so
Literally, right?
Okay.
You sit on and
So first of all, you need a point and a slope, right?
I got that.
To get a tangent line, a point and a slope.
No, just after I got lost after we changed 12.
Yeah, I got lost after that, like, what
Because I don't
did we change
understand
it
how we
from?
got 7.
Oh, you don't see how you got 7 here?
Because it's still 12 in the problem. It's not a negative 12. But how
Where
did
did
12
12 go?
have 4?
Hold on.
12?
Yeah, because if this is positive 4, then this will be 3 times 4, which is 12,
If you take the first
x squared
you shouldn't it be 4 times 2?
minus 5.
It's 4 times 3, right? If the coefficient is 3. To take the derivative, it's...
Does everybody see that now?
Is 12 squared
So if you find the derivative, d dx of 4x cubed minus 5x plus 3, our derivative of that is going to be equal to 12x squared minus 5. So now you have 12x squared minus 5, and then you plug in negative 1. Well, negative 1 squared is going to be 1, right? So what you end up with is 12 minus 5 or 7. So that's your slope, right? And then if you plug in negative 1 up here, you're going to have, instead of negative 4 times negative 1 cubed, negative 1 cubed is going to be negative 1. So that's going to be negative 4 plus 5 plus 3, which is 4. Right? So now you have, your point is this here, your slope is this, and then the rest of it is just solving for y, and you end up with y equals that. Okay? Is everybody okay with that now? So I was going, and I think part of it had to do with changing the understanding of that. I don't want to ask who got it right, because I think it was almost like a misprint the way it looked, because it looked like a negative sign. So I'd say, hey, let's not even count that one. Okay, based on the function given above, which of the following statements are true about f? The limit as x approaches 3 of f of x exists. I don't know, does it exist? Okay, limit as x approaches 3 of f of x equals question mark limit, actually as x approaches 3 from the left equals limit as x approaches 3 from the right side of f. You remember doing these, right?
Yeah.
And so you do that, you plug in on the left side, that's going to be this one. So what you're going to have is 3 plus 2. So that's going to be 3 plus 2. On the right side you have 4 times 3 minus 7. So we get 5 equals 5, right? So that's good. And so that exists, right? And also, is the function continuous? Yeah, because of this equal sign, right? It's going to have to be continuous. So we know that. We know it's not going to be choice A. We know it's not going to be 1 only. It's not going to be 2 only. So now we're between D. So now we got to check for differentiability, right? And so what is the limit as x approaches 3 from the left side of f prime of x equals question mark limit as x approaches 3 from the right side of f prime of x. We take the derivative of each. So this one here is derivative of 1. And the other one, the right side, is going to be derivative of 4. So what do we know? Not differentiable. And so now D is our right answer. How many got that one right? So a lot of you got that one right? Okay. Okay, this one here, we have y. This is the one that really we haven't covered a lot, but we have this y, this x plus cosine x at the point. So you have a point already, right? 0, 1. And what's going to be our first derivative? Y prime is going to be equal to 1. And the derivative of cosine is negative sine x. And how do I know that? if we do this SC, remember that? So derivative of cosine is negative sine. Okay, so that's a negative sine. It says at the point 0, so that's going to be that 1 minus sine x, that's y prime. And so what is our equation going to be? So this is going to be our slope. And so we have y minus y1, right, equals m, which is 1 minus sine x. And then we're going to have x minus 0, is that right?
Did you forget to put sine x
Sine x, excuse me, yeah, I think I did. Sine x, and then that'll be times, that's actually going to be sine, let me write it more clearly, because it's really ambiguous. Okay, sine x, we'll do it that way, times x minus 0, right? So we have, so that's going to be it. So our answer is going to be the equation of line tangent at this point. So we have is that a 4?
No, that's another one.
That's a negative 1? Because let's try if we plug in 0, we'll have it, right?
It might just be a 1.
It might be a negative 1.
I think it's just a.
I don't know, it's like.
Yeah, but there's like a big space between the column.
If we plug in, it's going to be just 1. Okay, it's actually going to be 1. Why is that? Because if we plug in 0 for x, well then we'll have 0 plus cosine 0, which is going to be 1. So that should actually be 1. Okay, so that's y minus 1 equals our slope times that. And then, so we get,
It could be a 4.
no, it's not. The reason it's not is because if you plug in 0 for this, you're not going to get 4. You're going to get 1. Okay, yeah, we have to, what it is, here it is, we got to plug in 0 for that, that's what we have to do. So let's go ahead and plug in 0 for x. So we have y at 0, so y prime for x equals 0 is going to be equal to 1 minus sine of 0. And sine of 0 is 0. So y prime of 0 equals 1. So our answer is going to be y minus 1 equals our slope times x minus 0. So that's going to be y equals x plus 1. So y equals x plus 1 is B. I don't know, that one, we didn't go over trigonometric ratios very much. And again, it's almost a reading issue on that one again. We're off to a good start on this. Okay, this one should be easier. What is this one going to be here? F prime of 5 is 1. Thank you. Yes. Why do we know that?
The derivative of x is 1.
Yeah, because f prime of x equals 1. So if we plug in 5, it's going to be 1 everywhere, right?
Yep.
So that's going to be that one. Next. That one was actually legible and pretty fast. That was a good one. It's easy, but okay, yeah, we didn't do one like this because the trigonometric ratios are more complicated. So let me just show you quickly what this is. What it is you want to find dy dx, the derivative of that. So y prime is going to be equal to the derivative of tan x is secant squared x. Secant squared x, derivative of cotangent is going to be negative tan cotangent. Let me see. Let's see, it's tan sec sec. I'm just trying to remember the rules. And then we have cotangent. Derivative of cotangent is going to be negative cotangent CSC CSC. And so we're going to have our derivative is going to be equal to negative, derivative of that's going to be negative cosecant squared x. And so what you're going to have is minus negative cosecant squared x. And so that's going to be positive. So this, in this case, our answer is E. I don't know if you got that. If you did, you probably guessed at it or got a lucky guess because we didn't cover that yet. All right? So this is one that definitely I would have expected people in this class to get by now. Okay, next. This one here, you have this, a particle moves along. This is a calculator problem. It says the position given by this one here, what's the velocity when its acceleration is 0? Well, how do you find acceleration? Acceleration is the what? It's the first derivative. I mean, it's the second derivative of that, right? So S prime of t, which is equal to v of t, is equal to our derivative of this. Well, it's going to be a negative that with sine, so that's going to be negative 4. Actually, it's going to change signs, so negative 4 sine t. So that's going to change signs, minus 2t over 2. So that's going to go away like that. So our second derivative, our acceleration of t, is going to be equal to s double prime of t, which in this case is going to be, it's going to be cot 4 cosine t, and what's our derivative of t? 1. So we have that, and when its acceleration is 0, so if we set that equal to 0, so 0 equals 4 cosine t. So we have you add 1, so 1 equals 4 cosine, I put cosine t, that's supposed to be cosine t, 4 cosine t, and so you have cosine t is equal to 1/4, and so we're going to find out what t is. How do you find that? When you go here, you say you want inverse, got to make sure we're in radians, so inverse cosine of 1/4, well, inverse sine of 1/4, or was it inverse cosine? It was inverse cosine, wasn't it? Yeah, inverse cosine of 1/4. Inverse cosine of 1/4. So this is going to be our t value, and we plug that in 1.318, which it's not going to be this one here, 1.318. We've got to plug this into our velocity. So we take that and plug it in to here. So what I'm going to do is I'm going to put storage x and then put 4 cosine x minus 1. So storage x and then 4,
4 cosine.
yeah, something was wrong, something, I did something wrong here.
4 cosine.
Okay, that's a first. Okay, no, we got, it's gonna be this one right here. It's gonna be 4 sine x, because we want to find the velocity, right? So we gotta plug that into here. So 4 sine something minus that, so 4
sine
4 sine x
x minus,
minus x
yeah.
minus x. So we should get that, 2.55.
D.
2.55. Yeah, D, okay. So yeah, this is definitely calculator 1. And then on this sheet here, is the next one the last one on that? Or was that the last one?
That was the last.
That was the last one. Find the, so we'll start tomorrow, kind of finishing this up. Let's go and do this one quickly. State the limit.
We don't have that.
You don't have this one?
No.
Okay, well, let me I'll figure out which one I gave you, so we can just leave it
We
there.
have before chain rule,
Before chain rule one?
that's on the top.
Are we trying to put that?
Yeah, you can turn that one in, that's fine. I'll figure it out. Thanks, ladies, appreciate you doing that. We'll just leave it there today. Plus, we're gonna go back to area underneath the curve, then go into estimations of integrals.